Today we will solve one Thevenin's theorem problem where two voltage sources are present. That is, one is 20 voltage source, another is 10 voltage source. Here the question is, we have to find out the current through 10 ohm resistance using Thevenin's theorem. So what to do? So for Thevenin's theorem, what we know? We know that any network can be transformed to a simple circuit which contain a voltage source and a series resistance So here this one is the RTH, the equivalent resistance of the network, and this one is the VTH, is the open source voltage. VTH is the open source voltage. Then you can connect the load. Then current through the load resistance, that is IL, is equal to VTH by RTH plus RL. So this one is the equations. We will use that one also. Now we have to find out the RTH. What are the steppings? Steppings is, for solve this Thevenin's theorem problem, steppings is, first we have to remove voltage source or replace voltage source by short circuit, and remove the load resistance. Then redraw the circuits. So there will be 5 ohms, 15 ohms, and this is 8 ohms, this is 2 ohms, and this one is terminal 1 and terminal 2, or I can write A, B. So AB is the load terminal. Now this is 5 ohms, this is 15 ohms. So we have to look at the load terminal. 8 ohms, this is 2 ohms. What we can see, this 5 ohms, so we have to find out RTH. So R equivalent circuit of this network can be find as so what we can see in this diagram, this 5 and 15 are parallel, and 2 and 8 are parallel, then series. So 5 parallel 15 plus 8 parallel 2. So this is 5 into 15 by 5 plus 15, this is 20, plus 8 into 2 by 8 plus 2, 10. So what we can see, this is 4 and this one is 5. So this is equal to 15 by 4 plus 8 by 3. After calculations, we can get this one is equal to 5.35. I am requesting all students to use the calculator. Use of scientific calculator properly during exam time is very, very important. So RTH is equal to 5.35 ohms. So whenever you solve Thevenin's problem, first remove the load resistance, then replace the voltage source by short circuit, and if there is any current source, replace it by open circuit. Now our objective to find out the current through 10 ohms. So here we have to check the potential at V at this point A and at this point B. We have to find out the potential at A and B. So in this figure, this is A, this is B. So current, if we use the nodal analysis, the voltage at A, that is VA, is always positive. And when you consider the node B, that time VB is always positive. So here we will use the nodal analysis. In many way you can solve network problem. So individually you can find out the current also, then find out the voltage. Now I can write VA minus 20 is one current. We know that current at any particular node is equal to 0. The sum of current at particular node is equal to 0. So there is current in these directions, current in these directions. So as we are opening the 10 ohm resistance, so it must be here. Here we will connect the voltage source again. So VA minus 20 divided by 5 is one current entering to node A. And the current is this VA by 15. As this one is the reference line, always it is 0. So plus VA by 15 is equal to 0. So here VA by 5 plus VA by 15 is equal to 20 by 5, that is 4. So this is 3 VA plus VA is equal to 4. So this 4 VA is equal to 60. So VA is equal to how much? This is 60 by 4. So this is 15 volt. This one is at node A. Now at node B, again sum of current is equal to 0. So what are the current? VB, send node voltage at B is equal to VB. VB minus 10 divided by 2 is one current, plus VB by 8 is another current, and sum of current is equal to 0. So this is VB by 2 plus BB by 8 is equal to minus 10 by 2. This is minus 5. So this is equal to 5. This is 4BB plus BB is equal to 5. So here it is 5 BB is equal to 8 into 5, this is 40. So VB is equal to 8 volt. Now the potential between VA minus VB, potential difference between VA minus VB, say this one is the V. This is equal to 15 minus 8 to 7 volt. Now we have the open circuit voltage. Open circuit voltage, this potential is V, and this is one is 7 volt. And we also know the equivalent resistance is 5.35. So now draw the equivalent circuit. So this one is the 7 volt, this is 5.35 ohm, and this resistance RL is equal to 10 ohms. Now current through the 10 ohms is equal to, so this is IL. So IL is equal to 7 divided by 5.35 plus 10. This is equal to 0.46 ampere. So this way you can find out the current through the load resistance. So what is new in this problem? In this problem there is 2 voltage source present. Generally, if multiple voltage source is present, we can use the superposition theorems. But here in the question it is mentioned you have to use Thevenin's theorems. So that means ultimately you have to draw the Thevenin's equivalent circuits. So this figure is Thevenin equivalent circuit. So this is your desired answer. So tomorrow we will solve Thevenin's problem with dependent source. Thank you very much for watching. Please like, share and subscribe this channel.